Moments question 3. So here we've got a diagram which is half drawn. We can put in the force arrows and the distances. And the first job is to calculate the reactions at P and Q, which we hopefully will be able to do. But it's the point B I'm interested in, this idea about it tipping. Okay, so we'll have a look at that. So let's put in some information. We've got a uniform, again, rod. So that weight acts in the centre. So watch out, because if it says a non-uniform rod, you would have to put the mass obviously somewhere, but you don't put it exactly at the centre, and probably the distance is then what you're working out. So just label a missing distance somewhere. Okay, so if that said this wasn't uniform, I'd still put a 9g down, but I'd label a distance maybe of x to that pivot point P. Okay. We haven't actually got any other weights on this at all. Okay, but it's resting horizontally in equilibrium on two smooth supports at P and Q. So we've got these two forces here. And let's label some distances. So we have 1.2 between A and P. We have 1.5 to the centre. So that's 0.3 between P and the centre. We have A to Q is 2.6, which means that gap's 0.4 and that gap's 1.1. Okay, so just check if all of that makes sense. So that's 1.5 to the centre, another 1.1 means it's 2.6 away from A, or it's 0.4 away from the other end. So make sure you've got all your individual little lengths labelled. Right, okay, so to do part A, I'll just give you one version of it. I'm going to pivot at P and work out the force at Q, and then we're going to resolve vertically. You could, if you preferred, pivot at Q, okay? But because we've got to talk about part B as well, I don't want to make this video too long. So I'm going to pivot at P. So I'm going to imagine that this object is fastened or pivoted here. The 9G is going to try and pull this side down, and the RQ is going to try and push it up. So these are the only two forces that are going to come into my equation. This one won't come into it because it's distance 0, and there aren't any other forces anywhere. So I'm going to have 9g multiplied by 0.3 one way, and that will equal RQ times a total distance, and then look, add those together, and that's 1.4. Okay. So as I said in the previous video, if you have been told or taught to do one force minus another force equals 0, that's absolutely fine as well. Okay, let's work this out. 9 times 9.8 times 0.3, and I'm going to just divide that by 1.4 immediately, and that gives me 18.9 for the reaction at Q. That's newtons. And then rather than pivoting at Q as well, I'm just going to resolve vertically. So here I have two forces to add together, RP plus RQ, and that will equal 9G. I already know RQ is 18.9 newtons. So I just need to work out 9 times 9.8, take away 18.9, and that gives me 69.3. Okay, let's move on to part B. So we have something changes now on the diagram. So as soon as you have an additional weight, or you add or subtract something on the diagram, everything else that you've calculated is probably going to not be those values anymore. Certainly if you include an extra mass, that's going to change all of these reactions. So you can't use these answers that you've got from part A. So let's draw it in. It says whether an additional particle of mass 3 kilograms is attached to point R of the rod. Now we don't know where that is, so that's annoying. The rod is on the point of turning about P. Calculate the distance AR. So we have to think through this before we panic. Okay, there's the rod. P's this side. That's the point it's going to turn around. Okay, now it's not going to tip that way. Let's actually place it over here. It's not going to tip that way because there's a support in the way. Okay, so if you put something heavy here, it's just going to increase these forces. It's not going to make it tip. Whereas if you put something here and you pushed it down, it could tip. Yeah, so you've got to think about where this extra object could be placed to make it be on the point of tipping up. Okay, and in this case we're going to say somewhere on this side. I don't know where. Okay, now I've just drawn that diagram so far because if you're at the point of tipping about P, okay, and if you imagine I was pushing down with my finger, but not very hard, okay, just enough to make it start to tip, what happens is the support here at Q is basically just not needed. Okay, I know I'm videoing from above here, but if you've got it resting on 2 supports like that, and then I push down on this end with this finger here, we're just at the point where it can be perfectly balanced with this support not needed. Okay, and if I push any harder, then it's going to tip up. So that's why I'm not even going to draw Q in. I'm just going to write Q is 0. Okay, so you're pushing with a force of 3G. We have a missing distance, okay, but we can work out that distance. So let's take a pivot point at P. Let's call that distance X for now. That's still 0.3. If we're in equilibrium in this situation, when we take moments about P, our equation would be 3G times X is equal to 9G times 0.3. Okay, we can work out what X is from that equation. Okay, you can cancel your G out or you can leave it in. I'll leave it in for a change. So 9 times 9.8 times 0.3 is 26.46. 3 lots of G is 29.4. So 26.46 divided by 29.4 is 0.9, which is a nice answer, which is promising. So let's make sure we've answered the question. Actually, the question wanted the distance from A to R. So if you're putting your object at point R, what it actually wanted was that distance that I've just put the question mark by. But remember, we know the whole distance between A and P is 1.2. So then we can figure out that, minus AR must be 0.3 meters. Okay, so sometimes the distance that you are asked to find, you need to then figure that out at the end. I would probably put in a missing distance as a distance to the pivot that you're going to use. And then you can work out the answer to the actual question at the very end. Okay, so this idea about it's on the point of turning, they might say it's in limiting equilibrium. It's just on the point of tipping. Yeah, this idea that you can have one reaction force go to 0. Okay, because if I push down with just the right force, at just the right distance, then that is going to remain horizontal, but that reaction force, that support isn't needed. So that's the situation. And if it's going to tip, it's going to tip about point P. Just think about which point it will tip around as you're answering this question. Okay, I'm loath to say common sense, but it almost is, isn't it, really? So think carefully about what the question is telling you. Okay, if you spot this sort of tipping question, you need to think, okay, which is the point it will tip around and which is the support that will not be needed. Okay, so if we'd put a heavy weight at end B instead, then Q would be the tip point and it would be support P that would not be needed. It would be that one that would go to 0. The moments questions can be quite difficult. Okay, so you just have to try and apply the steps that I've shown you, the moments and the resolving vertically, okay, in whatever situation you're presented with. All right, you're not going to have to do anything other than those two tactics, but they could give you a difficult question.